In this module, we are going to look at three more patterns to common Atom-Sphere integrations. That will be the general queue, paginated API handling, and parallel processing. We will first look at the general queue. A queue is used to assure document delivery. Messages, not documents, are managed by a shared queue server embedded in the Atom Java process. The queue functions can be provided by a third-party service like Amazon SQS. Messages consist of references to documents rather than actual document content. Each message references one or more documents. Messages must be explicitly pulled from and deleted from the queue. Queue provides the ability to rerun the transactions in a message by accessing the queue to read the message again. You can think of the queue pattern as a specific implementation of accumulate then process that we covered in our last module, where accumulate then process is more general and you can use any intermediary for different reasons, like managing load peaks. Queue is specific to assured document delivery. It gives you a place from which to rerun the document, plus it has built-in sequence and status. You would use queue when you want to enable simple, reliable, asynchronous process execution, and when you require the decoupling of the producers and consumers of messages. You would use this when messages need to persist to facilitate additional processing, and it provides resiliency in that producers can continue even if consumers are temporarily disabled or unavailable. So an example of this is a retrieval of information from services which are inherently unreliable. The separate processing allows for more granular retries. This illustration is a solution diagram. The contributing queue process, we will call that process 1, gets transaction records from a source that cannot be requeried to rerun the transaction. So process run puts the result records into the queue. The relieving queue process, we'll call it process 2, retrieves records from the queue and attempts to process them into the destination system. Failed records are restored to the queue for a retry, a maximum number of 6 tries, or successful records are explicitly deleted from the queue. There are 3 design considerations. Because this pattern utilizes 2 processes, you will need to decide where to handle duplicate records or documents, in the contributing process, as in process 1, or the relieving process, as in process 2. Another concern may be volume. If the queue volume could be too large for the relieving process, then consider running the process in parallel or in multiple instances. This pattern is specific to the Atom queue. Any queue message handling service will work, but you will need to consider how the handling is done so that you design your relieving process correctly. If the queue deletes the messages after they are retrieved, then you will want to put failed records back into the queue. If the message in the queue are persisted, then after those records are successful, you will need to delete them from the queue or they will process again at the next execution. Here are a few runtime considerations. Of course, the runtime will need access to the queue. Schedule queue access to match your business requirements. Monitor volume fluctuations to tune performance. Or, as the last slide mentioned, possibly implement parallel processing. There are similar errors here as to the accumulate then process pattern errors. If the source isn't in the contributing queue process, then Boomi needs to query again. If that process cannot reach the queue, then it needs to try again. If the retrieving process cannot send to the end system, then push back into the queue if necessary and try again. In this sample process, we are querying for account data. The process is showing starting with a no data and then a message shape, but you can imagine a start shape connector is there. The data is then split and goes through a try catch before sending the documents into the Amazon SQS queue service. This is the contributing queue process. This is the retrieving process. It starts by querying the queue for messages. The decision shape checks for data and then goes into a try catch. We have separated the processing into sub-processes, one to upsert into Salesforce and the other to delete the messages in the queue if the upsert is successful. We won't go through this in detail, but this process will differ based upon your own implementation. But the records are written into Salesforce and a decision shape checks to see if they were successful. Nothing is returned to the master process. The second branch of the master process sends successful documents to this subprocess, which deletes the records from the queue and then stops.